Pac-Man, here's a cool video about the sun's past.
Hello mortals. Remember the Archean Eon? Yeah, those were the good days. The era that started 4 billion years ago, or half a billion years after the Earth's formation, when the asteroids stopped falling in abundance and the crust had cooled enough to permit the formation of continents. The weather then was pretty comfy, almost no free oxygen in the atmosphere, but at least there was liquid water, and the temperature was near modern levels too, almost as good as an industrial zone in Eastern Europe. Thanks to Blinkist for sponsoring this video. The presence of liquid water at that time was crucial for single-celled organisms to start evolving and lead to today's abundance of life on Earth. There's a small problem, however. The source of all heat and light on Earth, the sun, was far fainter than it is in our days. Thus, it was burning at only 70% the intensity that it does during the modern epoch, which is quite a considerable amount. If the sun was as pale today, the Earth's overall temperature would drop down from plus 15 to minus 20 degrees Celsius or 60 to minus 4 degrees Fahrenheit, which is way below the freezing point of water. That means that large parts of Earth's surface water should have been frozen for a minimum 1 more billion years, which would be incompatible with the rise and the development of the first life forms, which of course, does not correspond with the fossil studies, geological evidences and the fact that you're now a complex multicellular walking calculator and not just a stupid amoeba.
Or are they?
First of all, let's clarify why the sun was 30% dimmer than it is today. Our star gets its energy by burning hydrogen through fusion. Under very high pressure and temperature, 2 or more protons will collide in order to form deuterium, helium-3, and finally helium-4. After this reaction, roughly 0.7% of the mass of the particles that collided transforms into energy, which catalyzes further reactions and casts radiations into outer space. The resulting helium can't fuse under these conditions, and it's also heavier than the nuclei of hydrogen flowing in the outer layer of the sun. Because of that, helium starts sinking into the very core of the sun, and because there is no fusion to keep the equilibrium between gravity and outwards radiation, the core contracts itself more and more, and the energy produced from this sinking heats the outer layer of the sun even more. So, by burning more hydrogen over time, more helium is produced that additionally heats the sun. Because of that, the sun's production of energy and radiation grows linearly over time. That means that the present-day sun is 1.4 times brighter than the sun from the Archean Eon. So then, how come life could have existed back then?
Maybe the rocks were still really hot.
Here's another question. How come life even exists at all?
Like when you turn off the stove,
the father of evolution
it's still
first
hot,
published his ideas
for a long
on
time.
the topic in the book, On the Origin of Species. It's 500 pages long and you might find it somewhat boring, so if you don't have time or desire, I have good news. Blinkist, our today's sponsor. They read this and a lot more books for you and condense them into 15-minute long high non-fic investments, which you can cancel if you want. Why then Earth wasn't a snowball? The most straightforward explanation would be a massive blanket over our planet that would keep it warm enough for water to remain liquid. But sheep weren't invented back then, so the blanket should have been made out of some material other than wool, for example, various gases that could maintain a greenhouse effect. Great amounts of gases could potentially trap enough heat from sun into the atmosphere to keep Earth warm. A candidate for a greenhouse gas would be ammonia that is very effective at reflecting heat, and it wouldn't require a big quantity of ammonia to keep the oceans warm. But the ammonia gas is easily photochemically destroyed in the atmosphere and converted to nitrogen and hydrogen. Another good candidate would be carbon dioxide. The primary mechanism for attaining high concentrations of CO2 is the carbon cycle. But an effective cycle of carbon dioxide requires life forms that would pull it off from rock sediments. It's hard to get carbon into the atmosphere without microorganisms that produce CO2 and methane, or overly smart monkeys that burn it out of the ground. A solution for high quantities of carbon in the atmosphere early in Earth's evolution would be a continuous bombardment of primordial asteroids. Celestial bodies of roughly 100 kilometers in diameter upon impact with the Earth's surface would melt large volumes of rock, creating Another theory says that in its early evolution, the sun was far more unstable and chaotic, Star underwing those so inside gradually indeed was indicates structure.